can calculate Expectiminimax by considering my remaining utilities would be optimal. And if I consider that, I can calculate my expecting value. Hey everybody, welcome back to Farzin Academy YouTube channel to Artificial Intelligence course. We are still in chapter of games and adversary searches, and today we want to talk about stochastic games. I strongly recommend to you, if you haven't watched 2 previous videos yet, I provide the link of the playlist of Artificial Intelligence course, so click on that and go and watch those videos first. First one was about Minimax algorithm. I talked about how this algorithm works. I talked about game tree and how minimizing player and maximizing player behave. And in the second video, we talk about alpha-beta pruning. That was very important to prevent checking unnecessary nodes in our game tree. And those videos are necessary for you if you want to understand the contents in this video totally. So, and please subscribe my channel, like this video, leave a comment and share it with your friends. That would be a big help for me and my channel. So let's start this video. What is stochastic games? So far, we've talked about games that there was no element and factor of chance or stochastic at those games. Like chess. A game like chess, 100% depends on your skills. But some games depends on your skill and your chance. Like what? Like games that you use dice, like backgammon. Do you know backgammon? It's a very beautiful Persian game. Each player has 15 beads. One player has white beads and another one had black beads. And at each turn, one player toss 2 dices, and according to the numbers that are shown, each player make a move. That is a very, very beautiful game. If you don't know that, go and learn. That's very beautiful. You're gonna enjoy that. By the way, these games that you toss a dice and according to the number on the dice, you make your move, or the games that you have cards and each card has a different value. These games depend on your skill and your chance. So if we want to study games in artificial intelligence, we have to consider this factor of chance to make our agents better. So there are terms that we should know. First one is chance node. Of course, when we have a chance node, our game is a stochastic one. So a node inserted into the game tree before the player's move whose outcome is non-deterministic. So the important thing here is our paths are not deterministic. It means according to our chance, because of the dice or a card, we can find our next move. Next term is expected value. That is the mathematical expectation for a chance node. So this is just like calculating expectation. I think you're already familiar with that because of some courses like probability and statistics. That's just like calculating average. And finally, we have Expectiminimax value. That is the best attainable utility for the given chance node under optimal play. When you want to calculate your Expectiminimax value, it's just like you have some nodes and you don't know other nodes yet. So you consider your remaining nodes that you don't know about them are in the best way, they are optimal, and then you calculate your value. That would be Expectiminimax value. But expected value is the real value. That means you know all your chance nodes and you calculate that based on real numbers. Let's see examples that would help you better to understand. First of all, we have these symbols that you have to be familiar. So far, our nodes are like triangles. A triangle with direction to up was minimizing player, and the triangle with direction to down was minimizing player. But here we have a new node that would be chance node, and we show that with a circle, as you can see here. So these circles are our chance nodes, and we have utilities here. You know that's already. But here we have some probabilities on our edges from chance nodes to our utilities. So there are probability and our chance node. So how to calculate expected value? This is pretty simple. Consider I reach at this point. So this chance node is complete and I want to calculate expected value. All I have to do is calculate mathematical expectation. That is pretty simple. I see for the utility of 3, I have probability of 0.3. So I calculate 3 times 0.3 and I add it to this probability that is 0.7 times 5, my utility. So I calculate this addition and that would be 4.4. So consider this is another utility just like this squares with value of 4.4. So all we have to do is calculate the expectation value of this another chance node. And because this node is a maximizing node, if the value of this node is more than our node, we pick that. And if it's less than this, we pick 4.4. So let's go. We have a utility of 1 with probability of 0.6, we have 5 with probability of 0.3, and we have 9 with probability of 0.1. So if I calculate expected value, that would be 1 times 0.6 plus 5 times 0.3 plus 9 times 0.1. That would be 3. So my node is maximizing, and that is obvious. 4.4 is more than 3. So my maximizing player pick the left branch and its value would be 4.4. So this is very easy. This is how we deal with stochastic games and element of chance. But we can apply pruning in stochastic games too, just like we apply that on normal games using alpha-beta. And that's just like that. We have to calculate expectiminimax value, and we can see if our expected value is not better than another expected value, we can prune the nodes. Like this example that I want to show you. We have this utility 3 with probability of 0.3, utility 5 with probability 0.7. If I calculate expected value, that would be 4.4. You knew that. Then I go for my another chance node. I have utility of 1 with probability of 0.6. And at this time, I wait, and I think I can do some pruning here. How I can do that? I don't know the utility of these remaining nodes, but I can calculate Expectiminimax by considering my remaining utilities would be optimal. And if I consider that, I can calculate my expecting value. So I assume the utility of my remaining values are 9, the largest number that you can consider, because these utilities could be between 1 and 9. If you consider that, the probability that left for you is 1 minus 0.6, because the addition of all probabilities must be 100%. So 1 minus 0.6 is 0.4. If you consider the most value that you can have here is 9, so you have to calculate 9 times 0.4 plus 1 times 0.6. That would be 4.2. And you see that 4.2 is less than 4.4. Your Expectiminimax is not better than the other utility. That means there is no reason that you go and calculate expected value for your remaining nodes, so you can easily prune your remaining nodes and prevent some unnecessary operations, and the branch that your maximizing player would choose is the left one, and its value would be 4.4. And at this point, we finished This chapter, it was about game, minimax algorithm, alpha-beta pruning, and chance element in our games that would cause stochastic games. In the next video, we will talk about constraint satisfaction problem, CSP, and please wait for that. So if you enjoyed this video, that would be a big help for me and my channel. To subscribe my channel, like this video, leave a comment, and share it with your friends who are interested in computer science and artificial intelligence. Thank you very much. See you later.